Our last video for lesson 3, as you can see, was all on solving equations. Our last video is going to be how do we solve a fractional equation. And I counted on the practice test, there were 4 fractional equations on the practice test, so I can assume there's going to be 4 fractional equations on the regular test as well in ALEKS. So as we said on the last page, if there are fractions, that should be step 1. Get rid of the fractions. You never have to solve an equation with fractions for the rest of your life after what we learn in this section. And it's huge for Math 126 because they have a whole chapter on solving rational equations, which is having polynomials in fractions. And it uses the same process. Multiply every term by the LCM or LCD, however you want to call it, and all the fractions disappear. It's a beautiful thing. This is probably one of my very favorite things in math, is I turn this ugly equation into a nice, pretty equation. So LCM, LCD are the same thing. So you're finding a number all the denominators go into. And for students that have a hard time with it, I just tell them the process is start with the largest number and start doing multiples. Does 4 go into 6? No. So this is 6 times 1, so 6 times 2 is 12. Does 4 go into 12? Yes. Does 3 go into 12? Yes. Does 6 go into 12? Yes. So there's my LCM. So that's the easiest way when there's multiples, is just pick the largest number when there's multiple fractions, multiple numbers, and just start doing multiples of that largest number till you find one that they all go into. And then the next bit of advice I'm going to give you is a lot of times students try to cram their work all into a little space. Write this really big, because you're going to be multiplying each fraction by 12 and you need a lot of room to do that. So then every fraction, and keep in mind, we're not making a common denominator. We're removing the fractions by multiplying by the common denominator. Because students always go, well, why didn't you put anything in the denominator? Because the denominator is going to go away. And the rule in solving equations is as long as you do the same thing to every term, you haven't upset the equality of the equation, the balance beam. So then this term gets multiplied by 12, and this term gets multiplied by 12. And it's always in the numerator because we're getting rid of the denominators. So this is what you should be thinking in your head. Just extend your fraction bar, and this is really 12x divided by 4. Well, 12 divided by 4 is 3, and then you have your x. Voila! Fraction is gone. And then this one is 12 times 2, 24x. So picture this, it's 24x divided by 3. That's what you should be picturing in your head. 24x divided by 3. Well, 24 divided by 3 is 8, and then you have your x. And I will tell you, lots of students lose their x's in this process. If the problem has an x, it stays with the x. So don't lose those x's when you're trying to simplify. So 24x divided by 3, 24 divided by 3 is 8x. And then this one, 12 times 5 is 60 over 6. So 60 divided by 6 is positive 10. Some students prefer to use a calculator. You can do that too. You can do 5 times 12 divided by 6 in your calculator. And you get the same thing. It's exactly what we just did in our head. 5 times 12 divided by 6, it gives us 10 as well. Okay, so you can check your work. Same thing here. You go 2 times 12 divided by 3, and don't forget your x. 12 divided by 4. So if you want to verify it on your calculator, you can certainly do that. And now, look at that. I have a beautiful little two-step equation. So that ugly mess turned into this. And I always ask students right now, how can you say math is not beautiful? That is such a beautiful thing that we just did there. Multiply by the LCM, boom, fractions are gone, and we just solve accordingly. So we need all of our x's on the left. So that would be minus 8x minus 8x, because we are crossing the equal sign, so we have to make sure that we do the opposite. 8 minus 8, 0. So 3 minus 8 is negative 5x equals 10. The opposite of times negative 5 is divide by negative 5. Double negative, that turns into 1x. 1 negative means the answer is negative. 10 divided by 5 is 2. And there you have it. Isn't that awesome? I think that's just such a beautiful problem. Nice, huh? Okay, I'm going to get you started on B, and then I'm going to let you turn off the video and try to finish solving it from there. So, when we look at B, we see there's only one denominator. When there's only one denominator, that has to be the LCM. You don't have any other choice. Common denominator is the only denominator. So what you're going to start on this one, let's write this one out big again. So this one, the LCM or LCD, whatever you want to call it, is 5. So let's write the problem really big. Spread everything out so you can multiply it all by 5. And one misconception students have is if it doesn't have a fraction, it doesn't need to be multiplied. That is seriously incorrect. You're upsetting the balance of the equation. The only way we're allowed to do this is because we did it to every term. You do not get to pick and choose which ones you're going to do it to. So it's every term or none at all. So in every numerator, we add 5. And it doesn't matter whether it's a fraction or not, it's all or nothing. And then I'll let you take it from there. So go ahead and shut off the video. Practice what we did over here and turn it into a fractionless problem and solve. Okay, so I'll see you back in a couple minutes when you're ready to check your work. Okay, the first thing I would do here is ding, ding. You could have changed this to 15 and did 15 divided by 5 and got 3. But whenever I see matching numbers, they're just gone. Because 5 divided by 5 is 1. But if you wrote 15 over 5 and then got 3, we'll get the same answer. So we're left with 3 times x minus 2 equals 3 times 5 is 15x plus 30. So now I follow the original set of rules. The original set of rules was get rid of your parentheses first. So 3x minus 6. And now we're down to just a little teeny two-step problem. X's on the left, constants on the right. So that ugly mess just turned into this pretty little thing. So to get my x's on the left, because I'm crossing the equal sign, I do have to do the opposite. So 15 minus 15, 3 minus 15 is negative 12x. Because the signs are different, subtract, keep the sign of the larger, minus 6 equals 30. And then anything without an x, meaning it's a constant, move it to the right. Add 6, So we get negative 12x equals, the 6's cancel, and that would be 36. And last step, get your x alone. The opposite of times negative 12 is divide by negative 12. And we get x equals 1 negative is negative, 36 divided by 12 is 3. Beautiful. So you can see, even when they're fractions, they're not hard. You just have to do that little step at the beginning, make them pretty, and then solve it just like all the other ones we've done. And then this one, negative 3, would be in solution sets for Alex. And you just check them the same. If you want to put them in and check them, you can. Okay, so what about decimals? Well, decimals really are fractions. This is 6 over 100. This is 10 over 100. This is 2 over 100. Right? Do you guys remember that from your arithmetic days? 2 decimal places mean put it over 100. So if all the denominators are 100, guess what I'm going to multiply by? 100. So for this one, and if you want to write that, you can see 6 over 100. And some students do this step and some of them don't. But it does kind of make it easy for you to see why you're picking 100. So this is, whoops, yep, 6 over 100x minus 10 over 100, x minus 2 minus 2 over 108. So if it's easier for you to visualize the LCD that way, do it. So if it's 1 decimal place, put it over 10, 2 decimal places, 100, 3 decimal places, 1,000, and we can easily see now our LCD or LCM is 100. So then we put 100 here. Extend that, 100 here. And the rule with LCD is you never, ever go inside the parentheses. It's only for the numbers outside the parentheses. And put 100 here. And the first thing I'm going to do is go ding, ding, and ding. Fractions are gone. So if you didn't want to change it to a fraction, you multiply by the highest number of decimal places. So the highest number of decimals is 2, so that's 100. So you multiply this by 100, which moves it into 6. You'd multiply this by 100, which moves it into 10. You multiply this by 100, which moves it into 2, which is going to be the exact same step we have now. So either way you want to do it is fine. So this first term is now just 6x. The second term is now 10, negative 10 times x minus 2. And this third term is now negative 2 times 8. And remember, I said multiply every term by 100. There's only 3 terms, so you should only have 3 hundreds in the problem. Because this is considered one term because there's no addition or subtraction. And the addition and subtractions inside parentheses here, so this is considered one term. Same thing here. And then you just have a simple problem. So 6x minus 10x. And here's where you need to be careful. Negative 10 times negative 2 is positive 20. That's another huge danger zone. Is when students are distributing, they forget to make 2 negatives a positive. They just always bring down that sign, and that's not the case. So negative times a positive, negative, negative times a negative, positive. And then a negative times a positive is negative over here as well. And there's our simple little 2-step problem. So we took that ugliness and turned it into this pretty little thing. So we do have some like terms to combine over here. So that's going to give us negative 4x because the signs are different. So we subtract and keep the sign of the larger. Plus 20 equals negative 16. So anything without an x moves right. So negative 20, negative 20. So we have negative 4x equals negative 36. Signs are the same, add and keep the sign. Divide by negative 4, divide by negative 4, so x is 9. Double negative, double negative. Beautiful, huh? Okay, then we have our two special cases, and you will have one special case on your test. You don't know which one it is, so I would probably highlight this just to remind yourself, because these are kind of a one and done thing. You see them in this one section, and then you don't see them again. So that kind of draws your attention there to make sure and look at the problem before your test and before your quiz. So special cases, what do special cases look like? Well, you're going to see in just a moment. When you start the problem, you'll probably have no idea it's a special case. So do it just like normal, no fractions or decimals. I don't have to multiply by anything, so I start by clearing parentheses. And anytime I see the same x on both sides, I know it's a special case. There's two types of special cases, and for some reason, students think all special cases are no solution. That is not true. Only 50% of them are no solution. The other 50% are just the opposite, all real numbers. So you want to do the next step so you know whether this is a no solution or an all real numbers. So all x's go on the left, and this is where most students make the biggest critical error ever. They cross this out, and then they write x here. 3 minus 3 is not 1. This is gone. So make a note to yourself. Never write x. 3 minus 3 is 0. You cannot bring an x down, and that's what most students do that miss this problem on the test. X means 1x. So you bring an x down, and that tells me you think 3 minus 3 is 1. It's 0. It's gone. So anytime the x's cancel on both sides, like I said, it's either going to be all real numbers or no solution. So we bring down the next step to determine. And I have this little saying that I do with my 126 classes. Always true, all real numbers. Keep the A's together. Never true, no solution. Keep the N's together. So is this always true or never true? Obviously, it's never true. 7 is never equal to 3. So never true means no solution. And sometimes they'll have you write the word no solution or pick it in your toolbox. Sometimes they'll have you write this as the no solution. So in high school, they let you do the little circle with the slice through it. They don't do that in college. So it's either going to be no solution, or it's going to be what we call the empty set, meaning there's no solution inside. So, and it all depends on Alex. If it gives you the no solution option in a drop-down menu or in the toolbox, you pick it. If it doesn't, you click on the solution sets in the toolbox and leave them empty. So that's how we write no solution in college, either with the verbiage or with the empty set symbols. In the next class, 126, they write it like this. Okay, next one's yours. So last one on lesson 3. So go ahead and do that one, shut off your video, and then come back and we'll check it together. Okay, let's do this. Last one for lesson 3, and we'll have 3 lessons down. So because there's no fractions, we immediately jump into first clearing parentheses, then combining like terms on each side. So 3x minus 3 plus 9 equals 8x plus 6 minus 5x. So parentheses are cleared. Step 2, combine like terms. So there's 2 like terms here, and there's 2 like terms here. And remember, we never combine with other sides. So 9 minus 6 is positive 3. So this is, or positive 6, excuse me. So 9 minus 3, positive 6, because we keep the sign of the larger. On the other side, 8x minus 5x is 3x plus 6. Same scenario as the last one. The x's match, so I know this is going to be either a no solution or all real numbers. Negative 3x, negative 3x, and do not bring down an x. They cancel on both sides. There is not one x left. There are 0 x's left, so we don't write anything. So we bring down the next line to determine if it's always true or never true. 6 is always going to be equal to 6. So because it's always true, remember the n's stay with the n's, the a's stay with the a's. Always true, all real numbers. And there's 3 different ways they have you write all real numbers in college, so I'll show you all of them. So all real numbers, they might have that in the toolbox to pick. Another way is using set builder notation for all x such that x is a real number. This is what they use in the next class. Students hate it, of course. But all this stuff is in the toolbox. You just have to keep clicking and make it look like that. So x such that x is any real number. But they say a real number, but it's really any real number. And the other way they let you write all real numbers sometimes is this. So that means any number in the world will work. Anything from negative infinity to infinity, you pick. So all of those mean all real numbers. They're just different ways. This is writing it with words. This is writing it with set builder notation. This is writing it with interval notation. Okay. So that's it. That's the end of lesson 3. So I'll see you back for lesson 4. Don't forget to do your hour to 2 hours of homework. Okay. Okay. See you later.